Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 2. Remember, chapter 2, we would focus on important characteristic of data, like we're going to focus on center, variation, distribution, outlines, and also time. That means any change in the characteristic of the data over time. If for some reasons you missed our first video on this chapter, section 2.1, frequency distribution for organizing and summarizing data, I strongly advise you to go back and check the video that I already posted on this on section 2.1, where we talk about how to develop ability to summarize data in the format of a frequency distribution and a relative frequency distribution. And for A frequency distributions, we identify values of class width, class midpoint, class limit like lower class limit, upper class limits, cumulative frequency, relative frequency. We talked about all of this in the previous video. But in this one, what we're going to do is really take a look on histograms. What we're going to do is to develop the ability to picture the distribution of data in the format of a histogram or the relative frequency distributions for quantitative data. We use histogram for quantitative data only, but for categorical data or qualitative data, we're not going to use histogram. We will examine a histogram and identify common distributions, like is it screwed left, is it screwed right, is it symmetric, or is it uniform? It all depends of the shape of our histogram. The histogram is just a graph. It's a bar graph that's attached to one another. We don't have time to check that. And hopefully, at the end of this chapter, we would you would construct a really a lot of frequency distributions. As key concept, as we said, while a frequency distribution is a useful tool for summarizing data and investigating the distribution of data, an even better tool is a histogram. Remember, frequency distribution is a table. That table you can do single grouping. Remember, one of the examples we went over is like the number of TV set per household. So at this point, you can have zero TV set, two TV, one TV set, two TV set, three TV set, four TV set, etc. So we call that a single grouping. But if we want to group student by age, because we might have students from 15 to 60 years old, instead of us do single grouping 15, 16, 17, 18, 19, 20, we can do a, um, a grouping, interval, class grouping, class intervals, where we might take maybe 15 to 19, 20 to 24, 25 to 29, etc. So we make a list of interval that we would count the number of data in each interval. So that's our goal when we construct the frequency distributions. Now, we said even though we could construct those graphs and you can clearly see how many data for each class or how many data per variables, we believe that histogram is a graph that is easier to understand and interpret than a table of numbers. So we know at some point a histogram is a graph consists of bars of equal width. That means for us, when we construct a histogram, remember we said for the histogram, the bars must attach to one another. So what we mean by that, if you construct a histogram, remember the height is the frequency, right? The height is the frequency, as we said. You can have another one, maybe like this. That's an example of you know that's an examples of a histogram. Suppose this is a histogram. Remember, it's a bar graph, but the bars attached to one another. We'll have a chance in a different video to construct histogram using Excel or StatCrunch, but in the meantime, I'm going to do it manually. Pay attention to the next video that where we would cover it using Excel or StatCrunch. So remember here, down here on the x-axis, that would be the class interval. All the classes would be here, but instead we would use the class boundaries. Of course, you would see that. And on this side, on the y-axis, we can either use the frequency distribution or the relative frequency distribution. Remember, the height of each bar depends on the frequencies. Now, we said the graph of consists of bars of equal width adjacent to each other unless there are gaps in the data. I mean, if there is zero, then we would say there would be a gap, maybe. The horizontal scales represent classes of quantitative data values. You see, we said quantitative data. It should be quantitative data, and the vertical scales represent frequencies. The height of the bars correspond to frequency values, or we can say it's correspond to relative frequency because it's similar. Important use of a histogram. So it's very important to see. Histogram help to visualize, visually displays the shape of the distribution of the data. All right, shows the location of the center of the data. It shows also the spread of the data. That means how far some data are from one another, and it has identified outliers. If you forget all these four concepts, I strongly advise you to watch the previous video because we provide some detailed definitions of distributions of the data, mostly when it's uniform, when it's symmetric, when it's screwed left, screwed right. Of course, we're going to have a chance to cover it again, the center or the average, the mean, of the data or the median of the data. So we'll have a chance to talk about it. Also, the spread, and the outlines, the data that's fall far away from the others, from the piles, from the majority of other data. Remember, we said um, relative frequency and frequency distribution, they are equivalent. That means they provide you exactly the same information, but on a different format. So frequency are all numbers. Like, if you count the number of of household that has only, out of 15 household, if four of them has zero TV, the frequency is 4, but the relative frequency would be 4 divided by 15 because the total is 15. So, which means it's exactly the same. The graphs are identical, especially on the horizontal scale axis, where you have the classes or the class boundaries, and but the vertical axis, which is the y-axis, it would be different because here, as you can see in the first graph, this is a frequency we use, 0, 5, 10, but on this side, it would be relative frequency. That would be relative, right? So which would be relative frequency on this side. As you can see, they provided in terms of percentages, but the shape, the height for each bars are exactly the same. All right. Now, very important when as we said, we talk about relative frequency that has the same shape and horizontal scales, all right, as a histogram, but as a frequency histogram, but the vertical scales use relative frequencies, all right, instead of actual frequencies. So that's what we just show you. But in the meantime, critical thinking, interpreting histogram, even though creating histogram is more fun than human beings could be allowed to have. The ultimate objective is to understand characteristic of the data, right? So what we can do, we can explore the data by analyzing the histogram to see what can be learned about CD dot, right? CD or C V dot, CV dot. All right. When we said C, is like for us is the center, the center of the data, right? Center, the median or the mean of the data. The V for variation, which will be we're gonna discuss it in section 3.2 very soon. The shape of the distribution, distant forest distribution, whether there are any outliers also we need to take. See how is there are there any values far away from other values, and also T for time, okay, whether there is any change in the characteristic of the data over the time. So that's what we're gonna do. Of course, let's see some of the common distributions, say for histogram. So you see the first one is mostly a bell-shaped, distributions. It's really bell-shaped, right? It's really bell-shaped. So when graph has a histogram, that's a normal distribution or has a bell shape similar to many normal distributions. So if you want, when we say normal distributions, it's mostly you can go up smoothly and you reach a peak, then you can go down. And the maximum, that means the maximum for those of you who do this, is the mean. The mean is falls right here. The mean equal the median anyway, but a split your graph 50-50, then it's symmetric, right? It's symmetric about the mean. It's really, a normal distribution because many statistical methods require that sample data come from a population having a normal distribution that is approximately a normal distribution, and we can often use a histogram to judge whether this requirement is satisfied. But the second one, as you can see, all the bars are the same height. Okay, the second one, you can see the bars are the same height. We call this one a uniform distribution. It has a uniform distribution because most of the one in red, of course, you can see is a uniform distribution. So this one is symmetric, as we said, symmetric, uniform. But look at this one. Look at the third one. The third one is mostly you go up very quick, but it's spread out more on the right. You see, on the right, we call this one we screwed right. So remember, screwed right means the tail on the right, a distribution of data is good if it's not symmetric and extends more to one side than the other side. Like data skewed to the right, also called positive skewed, have a longer right tail, right? But it has a longer right tail. But data skewed to the left, also called negative skewed. Look at that. I'm going to use this one. It's the tail is longer on the left. See? So we call this one skewed left. Skewed left because the tail on the left is longer, right? So hopefully you can see these four, of course, and you can see these four and review them anytime you want because we're gonna ask you anytime what type of distribution is this particular graph that you would construct in the future. As we said, normal distributions because this histogram is roughly bell-shaped because normal distributions, remember, it's always that smooth graph that goes up right in the middles. You hit the peak and you goes down like a bell shape. Then we call it's a normal curve. Of course, we're gonna have a chance in the next chapter 5, 6, and 7 to talk about normal distributions again in a larger scale. So skewed left or skewed right, as we said, a distribution of data is skewed if it's not symmetric and extends more to one side. So that's what we said here. For example, this one skewed right. I showed you here because I could choose not to put them twice. And this one screwed right, left because it takes longer to go all the way up. As we said, we call that negative screw that have a longer left tail. Okay, so that's very important to see this part also. So I think we're ready to construct some histogram because it said construct the histogram and answer the given questions. What we would do, use the distribution, the frequency distribution of the data set below to construct a histogram. So because we did that one before, I'm going to use something, I mean, the tables because they ask you to construct if to use the frequency we could use also relative frequency. What I'm going to do is go back wherever we construct with the same data because I'm using exactly the same data. Is it this one? Nope. For this one, no, not this one. I believe that the one we use, right? um I'm going just to take everything because you did it before. Okay. I'm going to copy. For these distributions, you would see if I believe it's the same thing. So I don't want to reproduce everything, but I take whatever I have already. So you know what? Let's do it. Because what I did, what I did in these examples, let's go ahead. I try to be lazy, okay? So forgive me to try to be lazy. I said I'm going to copy this because I already construct, but if for some reasons you forget it, I can still go back and do it. Okay, remember what I did here. I'm going just to explain. In this data set, what they were asking us to do, um, you know, what they were asking us to do is to construct a frequency histogram using the width. Remember, in that data set, what we did, we identified the width. So the width, the minimum in that data set was 4, and the maximum, the largest number in that data set was 80. So remember, this is the minimum, and that was the maximum. The largest number, the smallest data in the data set, and the largest data in that data set. And also, they did ask us to use the width in that particular examples because we're gonna use exactly the same thing. Use the width 15. So it's for some of you, if you forget how to do it, remember the width, how to construct your class. They said start in that examples. If you forgot, I would strongly advise you to review section 2.1. So we said that lower limit, start with lower class limit, 0. So if you start with 0, as you can see, 0 plus the width, which is 15, that make it 15. 15 plus 15, 30. 30 plus 15, 45. 45 plus 15, 60. 60 plus 15, 75. And remember, the smallest data must falls in the lowest, in the first class. And the largest data must falls in the last class. So that's exactly, we know the smallest number would fall anyway, between 0 and 14. And the largest number, which is 80, would falls in the last class, which is 75 to 89. So we know the number of classes here. We have 1, 2, 3, 4, 5, 6 different classes, and we count all the data. I'm trying to save time. That's why I tried just to explain what we did before. So class interval. So we count on the first class here all the data that are from 0 to 14 from the data set. Like I go, 0 to 14, I take 12, for example. I take 4, that's two of them. right? And if I continue, I'm pretty sure you're gonna see I take 10, that's 3. All right, I take 10 again, that's 4. I take another 12, that's 5. So that's how I found the number of data that solved from between, I mean, from 0 to 15. And I do exactly the same for each of them. Most importantly, because we need to know how many data we have in that data set. I believe it's 50. So we need to make sure that we add all the frequencies so we can obtain the total. The totals, when we said 5 plus 16, that 21 plus 14, that's 35 plus 9, that 44 plus 5, 49 plus 1. We know the total for this data set would be 50. So if you count the number of data in that data set, you would see also it corresponds to 50 different data. Now, what do they ask us to do? Use that data set to construct a histogram. When we construct a histogram, we must add another we must add a few other we must add a few other um columns. One of the most important columns we should add, we call it class boundaries. For the class boundaries, what we said, okay, it's usually you take point 0.5, okay, from each, I mean, unless you start with 0, but otherwise you take point 0.5 from each data, from each uh, class limits, and then a lower class limit, and you add it to the upper one, except when it starts with 0. Because we start with 0, but we're gonna still put this one is 14.5. But the next one would be 14.5. When I take 0.5 from this one, it's gonna be 29.5 because I add 0.5. Remove 0.5 from 30, it gives you 29.5, 44.5, 44.5, 59.5, 60. Instead of 60, we have 59.5, 74.5, 74.5, 89.5. The reason why we construct that colon is because if we try to construct our histogram, okay, okay, suppose this line is straight. Okay, if we go with our histogram with only the class interval like 0, 14, between 0, 14 and 15, there is a gap of 1. So because our histogram, all bars must attach to one another, we want to make sure what the upper class limit of a class of the previous class is the actual is the lower class limit of the current class. So meaning when we start with 0, then remember the next one was gonna be 14.5, 29.5, 44.5, 59.5, 74.5, and down here the last one is 89.5. Okay. Remember, on the x-axis, we add the class intervals, but we can, as I said, because it's a histogram, it's better we use the class boundaries. On the y-axis, we need to list all our frequencies. And first of all, you identify the largest frequency is 16. So we need to count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. I try to make it 16 this way. I try to put them very small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Feel free to do something different if you don't like it this way. All right. Now, the first from 0 to 14 or 0 to 14.5, the the frequency, remember this is the frequency on the y-axis. Frequency is 5. So this is 5 right here. So we know the first bar, the height would be 5. Well, actually, that's not, I need to remove it because there is no hours. Okay. Now, this next bar, 14.5 to 29.5 is 16. So we need to go all the way up there. Okay. It keep making it like there is no hours. Okay. So know that there is no hours. I don't know why it put hours. All right. No hours. Now, the next bars, from 29 to 44, it would be 14. So we know where 14 is located. 14 is right there. I would guess 14 is right there. And I will go up like this. Now, the next bar would be 9, from 44 to 59 or 45 to 59 is 9. So where 9 is located is somewhere here. So actually, I sketch it because I don't give you exactly the same thing. Okay. All right. Now, the next bar would be 5 again. So we're gonna go all the way down to 5. And the last one would be 1. Okay, remember, this is a frequency histogram. The characteristic, first of all, you need to make sure you use the class interval to construct the class boundaries. Take 0.5 from every lower limit and add it to the upper limit. So the current lower limit is equivalent or is the same as the upper limit of the last class, of the previous class. Okay, so that's how we do it so they can connect. Remember, a histogram is a bar graph where each bar is attached to one another. There should be no gap between the bars. As I said, I just go over these examples here with you, but know that we would have a chance to use Excel to construct these graphs. So, and you can see better because for some of your projects or homework, or you would need to do it using a technology or any device and some software or platforms. For number 2. Again, this is an examples we covered, but in order to make sure that you really get what we did here, I could still show you what we had from the previous examples. I'm going to explain what we did in that one, the one that starts with 57, right? All right. So remember in these examples, they did ask us to construct a frequency distribution for that data where we would use this edge, use a class width of 5. That means you see 40 plus 5 is 45, plus 5 is 50, plus 5 is 55, plus 5 is 60, plus 5, etc. And they said also for this particular one, okay, uh, start with a lower class limit of 40. So yeah, that's why you see we started with 40 instead of 0. The other one, the smallest number was 4. So starting with 0, we could start with 4. We could start with 1, 0, 1, 2, 3, 4, but we couldn't start with 5. Otherwise, 4, which is the smallest number in the data set, wouldn't fit in any class. So hopefully you got that. Let me copy this. I just want to save time constructing the frequency distributions. If for some reasons you really don't get it, I strongly advise you to go back and watch the previous video. All right, this is what it says. Remember from that data set where we talked about age, we did identify the smallest, so we did identify the smallest number in that data set. Remember, the minimum in that data set was, I believe that was 42, right? That was 42. And the maximum of that data set was 70, right? Was 70. And they told us to use the width from the previous exercise, of course. They asked us to use the width of 5. Okay, so the reason why I'm connecting all those homework together is because it's make it much easier to work with the data when we can use the same data set to answer multiple questions. So what we're gonna do here, because we know the width, and then all you need to do is add the width each time to the lower limit. First lower limit is 40 plus 5, 45, 50, and then wherever you start, so where you added with for the upper limit is 40. If you start the next class with 45, then you added with at you added at 44. Now, what we did in the previous examples, we counted the number using that data set. Using that data set, what we did, we count the number of data for each class. How many data you can identify from 40 to 44 was only 2. The number of data you identify from 45 to 49 was 7, etc. So that's what we did. Now, again, in order to construct, in order to construct a frequency, frequency histogram, a histogram using frequency, we need the class boundaries again. So, okay. How do you think we're going to find the class boundaries? Because we did it before, right? So class boundaries for us, that something we can do at any time. Class boundaries, meaning take 0.5 from the previous class. That means instead of 40, we're going to have 39.5 added to the next one, 44.5. 44.5, and you add 49.5. 49.5, 54.5. Those class boundaries are essential when you want to construct a histogram. Remember, histogram is only for quantitative data. That means numerical response. So 55, instead of 55, we're going to have 54.5, 59.5, 59.5, 64.5, 64.5, 69.5, 69.5, 74.5. So the reason why we do that, as we said, when you construct your beautiful histogram, where if you start with 0, here remember starting with 0, what I'm gonna do, I'm not gonna count with 0. So what I would do, I put this to say that we don't start with 0, but I'm gonna put 39.5, 44.5, 49.5, the class boundaries, right? 54.5, 59.5, 64.5. All right, we have 60 we have 69.5. Okay. We have 69.5, and we're gonna have 60 and 74.5. Okay. So all right, so we got uh Okay, sorry about that. All right. Now, you know, this is the class boundaries here. But on the, you know, um, okay, so, on the, y-axis, what we're gonna have, and then we would say, oh, you know what the smallest number is, what smallest frequency is 1, largest frequency is 10. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So this is what happened. You know, um, the first class has a frequency of 2. So we go up 2 for our first bar. Second bar, we go to 7. Well, they are not really uniform, but they must be uniform in real life when you use technology, right? But because I sketch it here, they're not really uniform. So 49.5 to 54.5 goes up to 10. And 54.5, 59.5, again, it's another 10. Okay. Now, let's see. It's 6 for 6, 59.5, 74. No, so that's 6. Okay, 63. All right. And then we're gonna have 1. Okay. So this is a frequency histogram. Now, the questions they were asking, probably I didn't answer from the previous one as well. The questions was, does it appear to be the graph of the data from a population with a normal distribution? Normal distribution, that's mostly symmetric, like really, it's not screwed left, screwed right. But I cannot say this one screwed left or screwed right. It's not uniform, it's mostly symmetric. So we can say yes, the histogram does appear to have a graph of a data from a population with a normal distribution. But if you look at from the previous one, it would be more like it's screwed right because it shows it's mostly screwed right. It's far from being bell-shaped. The histogram does not appear to depict data from a population with a normal distribution here, right? All right. Now let's do one more exercise. In this case, you will see it would be mostly single grouping. If I use the exact same one, I'm hoping we did it. We also cover it. Let's see if we go back that data set. Did we use it? Yes, we did. This data set listed below are the F scales and intensities of recent tornadoes in the US. So we construct a histogram. In this case, they don't ask us, we don't need them to tell us what would be the lower class because it's very simple grouping. And I don't need, you know, I don't really need, class boundaries to construct the histogram. Let's construct that histogram very quick and you would see how you're gonna like it. You're gonna enjoy it. All right, so we have this data set right there. Remember, the goal for us is to construct a histogram. When we construct a histogram, remember on the x-axis, well, we're gonna have 0, or if, I mean, I don't know if we can just put 0 like this, okay? I don't know if we can just put them as 0, 1, 2, 3. Let's see. Okay. For the tornado. Okay. Yeah. So we can go and construct it with the tornado. We're gonna have, I don't want to put 0. I'm gonna put this 0 different. Okay. So that 0 would be different because it's about the X scale. So we're gonna have 0 tornado, 1 tornado, 2 tornado, 3 tornado, and 4 tornado. Now, as you can see, um, the x-axis are the tornadoes, right? So that's the tornadoes. That's the x-axis, right? But the y-axis would be the frequencies. That's something we already covered. You just count the number of zero you see here. That's 24. The number of one tornado is 16. The number of two tornadoes is 2. The number of three tornadoes is 2. And the number of four tornadoes is 1. So what we need to do is really count by to go up to 24. So what I'm gonna do, I'll make it easy. I'll do 5, 10, 15, 20, 25. So that means 24 would be somewhere here. All right. And what we're gonna do, we need to make sure that our X value and the number of tornado would be exactly in the middle. It's like a midpoint. It would be exactly in the middle when we construct our graph. The first bar goes up to 20. Remember, the first bar must go up to 24. So what we're gonna do for 24, okay, we can go up here and we fall exactly halfway after 0. That's the first bar. The second bar must go 16, for example. So it's gonna go from here and to the middle between 1 and 2, exactly between 1 and 2. Remember, this is 24, this is 16, etc. We can continue. Two tornadoes. How many tornadoes? How many tornadoes? Two. So it's only two. So for us, probably two would be that one here. And three tornadoes, also two. And one tornado. So let's say one down here. And this is it. This is again another frequency histogram. Uh, Things you need to remember about histogram, bars are attached to one another. There should be any gap between them. On the x-axis, you have the class intervals or the number of x, or on the y-axis, you have the frequency. So all those graphs, usually we construct them using either the frequency distribution or the relative frequency for the histogram. So histogram, we only use it to display quantitative data, I mean numericals. You see all three examples here, we use them in that way. So in a different video, I would come by section 2.1 and 2.2 to do one or two example on Excel so you can see how to construct a frequency distribution and a histogram on Excel. Take care. I'll see you in a different video.